Hello, this is our final project, Human Head Tracking with MobileNet SSD model in real-time video. We will introduce our project from the following aspects. First, I will introduce our project. Detecting and tracking a certain object plays an important role in computer vision. It has many applications, such as human-computer interaction, robotics, visual monitoring, and so on. In our work, we address the problem of tracking human head in real time. The human head detection system must monitor whether anyone is entering the scene. Once the person is captured in the scene, the system starts to track that person. Next is our detection model. SSD, single-shot multi-box detector, is an object detection model that directly predicts small borders and target categories through regression and classification of feature extraction. The neural network used for head detection here is MobileNet SSD. It replaced the traditional convolution method in the SSD model with deeply separable convolution method. In the network structure, it mainly replaced the feature extraction part. The models are smaller and the computation complexity are lower. Using MobileNet SSD requires less detection time, which is beneficial to the real-time nature of the system.
Next is our tracking method. We use KCF as the head tracking method. It uses correlation filters which could calculate the different information between current frame and previous frames. But we can see from the video that there are some problems. The first problem is tracking failure. When the human head leaves the screen or is completely blocked by other people, the tracking frame will stay in the screen, which causes tracked object lost and tracking failure. The method adopted here is to delete the tracker when the track frame does not match the detected head for multiple times or touches the border of the screen. The other problem is tracking multiple objects. Multiple heads might appear in one screen. Therefore, the tracking method needs to have the ability to track multiple targets. Here, each head object is regarded as an independent object, a tracker. The historical position, speed, and the direction of each head object are encapsulated in their own objects. So the problem can be simplified to use multiple trackers to achieve multiple target tracking. Here is the result of multiple trackers.
The next part is our system structure. Our system has four parts. Input module reads the images. Head detection module detects the head position and gives it to tracking module to update the tracker. Tracking module is used to create and update all trackers. The position of each tracker would be shown in the output part. There are two input methods in our system. One is to read through the camera, the other is to read video files. The latter one is used for algorithm research and testing. Like introduced before, we trained the human head detection model with MobileNet SSD. It is used in this part. When a new frame is received, first it will check whether the head detection module is busy. Since the detection process is time-consuming, if the module is busy, the newly received frame will be cached in the historical frames. Otherwise, it will perform head detection on the current frame. After getting the human head position, the tracker is initialized based on the head area, like this. Then give the buffer frames to these trackers, so they could quickly update and track to the head position in the current frame, and finally transfer these refreshed trackers to the tracking module. The tracker is used to track each head and record their positions. When a new frame is received, if there are trackers in the pool, it will use these trackers to track heads. When a head is not detected by the detection part for 5 times, its tracker will be cleared. With the information of the historical position and frame rate stored in each tracker, we could calculate the head speed and direction of movement for future use. The next part is the demo of our system.
We use a laptop camera in real time to test our system. First, it detects a still human head. It also could detect and track a moving head. Next, it could detect and track the back side of a human head. Finally, when the head is blocked and the detection model cannot detect it for multiple times, or when its tracker touches the border of the screen, the tracker also will be cleared.